Chapter 10. How many of you guys are in statistics right now? AP Stats? Where are my AP Stats kids at? Nobody? Not one person. Yo-chan. Oh, yeah, he's not here right now. Shout out to Yo-chan on the video. All right, Chapter 10. He probably won't even watch this. He will now actually go, oh, Yo-chan, you said her name. All right, so Chapter 10 is all about statistics and probability. And we're going to do the kind of like an introduction, probability. If you want more, if you're just yearning for more of this, take AP Stats or take stats in college, okay? In college statistics, you can take basic stats, which is like you just pretty much need algebra to get into it. And then there's higher level stats. So there's like stats after calculus that uses calculus. And it's hard. It's really hard. I took a 500 level stats class 2 years ago. It's the only class I got a B in. Yeah, I'm pretty pissed about it. Okay, here we go. 10-1A. Ms. Cowie, our stats teacher, guess what she got? A+. She did. She probably got like the highest grade in the class. She's really good at statistics. All right, so here we go. We're going to start today with 10-1A, and lesson 10 is all about probability. And you're going to use some of that stuff that you just did on your test in order to find the probabilities of things. Like, probability is so important. We use probability all the time. What's the probable chance that it's going to rain today? Probably 0%, right? What's the probability that you have a math test today? 100%, right? Okay. In probability, there's some things that happen, and we're going to find the probabilities of stuff, and we're just going to talk about probability in general. So here we go. I've got A and B, just 2 parts, okay? All right, little introduction into what probability is. Here we go. Little intro. The probability of an event. So the probability of an event. So that means like the probability of something happening. We call that event capital E. With sample space. These are going to be some interesting words coming up here. Now, some of you guys had probability statistics a little bit last year in Algebra 2 honors, but not Algebra 2 regular. We don't get that far. So some of you guys are a little bit behind here, but that's okay. So the probability of an event E with sample space S is this. This is what it is. We write it like this. P of E, so the probability of E, is equal to the number of outcomes in E, the number of outcomes in E over the number of outcomes in S. Okay? So E are your successes. Like, let's talk about this test you just took. This test you just took, you're going to get, what, 93%, right? Something like that. No? Sam says no. 102. Yes, okay. All right. Well, in probability, you can't get 102, but on this test, you actually could. So probability would be the stuff you got right out of all of the stuff that you just did. Isn't that true? I mean, that's what your percentage is. That's what the probability is. The number of outcomes that you're looking for, successes, over total number of outcomes. So let's do some easy probability. Probability shows up. You know where it shows up? SAT. Anyone taking that on Saturday? Yeah? Probability shows up there. Shows up on SAT, ACT. So number 1, we're going to find the probability. Find the probability of these things. We'll do some easy stuff. Letter A. All right, let's find the probability that you toss a coin 2 times. A coin 2 times. And you get tails, tails. What's the probability that that's going to happen? Does anyone know? You know already? 2 over 4? Is that right? I don't think so, right? What's the probability that you get tails and then tails? 25. Okay, so we have to think about how many different outcomes are there. You could get tails, tails. You could get tails, then heads. You could get heads, then tails. Or you could get heads, then heads. Okay? So this right here is your success. That's the one you want out of how many total possible outcomes? 1/4. There's 25% chance that you're going to get tails, tails. 25% chance you get heads, heads too. 20 or 50% chance that you get one of each, right? Because it would be these two out of the 4. Yes?
Can you also find that by doing like chances of getting like tails out of heads, like one of these times?
Perfect. That's exactly right. Did you hear that? So the probability that you get tails on the first toss would be 1 out of 2. Probability that you get tails on the second toss would be 1 out of 2. And so you're right, 1 out of 4. That's another way to do it. A lot of times these ones have different ways to do them. Okay, do you guys know cards? Are you pretty good at playing cards at all? Some of you guys, I know I've had students over the years that have no idea what playing cards are. So I like to explain them. There are 4 suits in playing cards. Okay, so you have, what are they? Spades, clubs, diamonds, and hearts. Okay? And then for these, we have ace, king, queen, 10 down through 2. All right, so what's the probability that I have a random, or standard, not random, standard deck of playing cards? How many playing cards are there? 52. Do you ever play 52 pickup? Yeah, that sucks, right? That's how you remember it, huh? Me too. There are 52 cards. What's the probability that you just walk up to me, I have 52 cards in my hand, I say, pick a card. What's the probability that you pick an ace? Well, yeah, you got this one?
113.
You even reduced. Good job. Let's talk about that. There's 2 ways to look at this. There are 4 aces out of 52 cards in the deck, right? You could also think of it as for each suit, there's 1 ace out of the 13, and that actually reduces to 1/13. I like that you reduced that. Okay, let's do one more. What is the probability that you roll a sum of 4 with 2 dice? Okay, so you take 2 dice, you roll it out. What is the sum? What is the probability that you get a sum of 4 with 2 dice? Sorry, that looks really bad. 2 dice. Well, this one's a little tough. Let's find out how many ways there are to roll 2 dice, first of all. So here's our dice. There's 2 of them. And how many different things can you get? Standard regular dice. How many? There's 6 options, right? You could roll a 1, a 2, a 3, a 4, a 5, or 6. And then on the second one, there's also 6. So there are 36 possible ways total to roll 2 dice. You get a 1-6, a 6-1, a 3-4, a 4-3. Okay, all those different options. And there are 36 of them. They actually list them all in your book if you ever wanted to look at them. Now, what's the probability that you get a sum of 4? Sometimes it's nice just to write it out. How would we get a sum of 4? We could roll a 1 and then a 3. We could roll a 3 and then a 1. Those are different. And then also what else? 2 and a 2. Perfect. So those are my events. That's the event. That's the E part. There's 3 of them out of the sample space, and there are 36 in the sample space, total outcomes. So that would be 1/12. There you go. All right, now, they ask you also for something called probability distribution. Probability distribution. And I don't really like to waste our time on these. The table, they give tables of probability distributions. Oh, you decided to show up today. You had one of those, I feel sick, I have a test. No, I heard you're at the DMV. How'd it go?
They thought I was an illegal resident.
Okay, great. Did you? That's just awkward. Okay. They thought that he was an illegal person. All right. Anyways, but the probability distribution, there's one in your book. I don't want to write it out because we're running out of time here, but it tells you. It's on page 679. It tells you, like, look at. Here are all the different ways to roll 2 dice. And then there's the sum of them, and then there's also the outcome and probability. So rolling a 4 was 2 out of 36. They don't like to reduce a lot of times, which is fine. Either way. Okay. If you look at a probability distribution, it can help you find the right answers a lot of times. So probability distribution, page, what did I say? 679. That's going to help you out a lot for that. So like, for example, number, what are we on, 2? If we want to find the probability of rolling a sum that is divisible by 3. Okay? We can go to that probability distribution chart that they've already listed for us and find the probabilities of each of the things and then add them up. So numbers that are divisible by 3, what sums would that even be? That would be what? To get a 3, 6, roll a 9, like a sum. We're talking about a sum. Rolling a 9 or a
Are we still talking about dice?
12. Yeah.
Okay.
Yeah. So we're rolling 2 dice, and we want to find the probability of getting a sum that's divisible by 3. So those are them. I go to my probability distribution chart, and to roll a 3, it says would 2 out of 36. Oh, to roll a 4 was 3 out of 36. Sorry, I said 2 out of 36 earlier. To roll a 6 is 5 out of 36. The probability of rolling a 9 is 4 out of 36. And then the probability of rolling a 12 is 1 out of 36. 12 only has 1 because it's 6 and 6. That's the only way you can get a 12. And then you take those probabilities and you add them up. And so the probability that you're going to roll 2 dice and that sum on those dice is divisible by 3 would be each of these added together. They're all separate events. You don't want to multiply them. That wouldn't make sense. And it would be 1/3. And you add all those up. Yeah?
Can you go into like a little more depth as to like how we know when to multiply?
Yeah. That's going to be tough because we're not sure. Like, okay, if it's the same event, then you're going to multiply. Like, if you're talking about you pick something out of a hat and then you pick something again, you multiply those.
Okay.
But if it's really, if you have and, you multiply, and if you have or, you add.
Okay.
So and is to multiply. So remember that one we had a tails and a tails?
Yeah.
And usually you multiply, usually. There's always like weird things that show up. And then or, you're going to add the probabilities. Because if I say, like for example, I want to pull out of the deck a queen or a king. Am I going to multiply those together? No. I'm going to find out what's the probability of getting a queen, what's the probability of getting a king. I'm going to add them up because they combine to give me my total probability chance. Yeah. Oh, good. I'm glad that helped you. All right, here we go. For probabilities, there's a couple of things. Number 1, so probability functions. Bless you. So probability function, there's 3 things that happen. Your probability of an outcome, so I like to say probability of the event. They like to use the letter O. I hate the letter O because it looks like a 0 to me. So the probability of an event is going to be between or equal to 0 and 1. So like, oh, what's the probability that it's going to rain outside? 110%? No, not true. Okay? Can you get over 100% on this test? Yes, and people will. But you can't say that it's going to be 110 chance it's going to rain. Okay? So with probabilities, you're stuck between 0 and 1. It can equal 0 and it can equal 1, but you're in there. Okay? Also, the sum of all the probabilities. The sum of all the probabilities in an outcome is equal to 1. So if I say, what's the probability that it's going to rain tomorrow? Is 33%. What's the probability it's not going to rain tomorrow?
66.
What was it? 67%? 67%? You add those up, it equals 1. Those are all the outcomes that could happen. For these right here, in this distribution chart, if you add up all these outcomes, it will equal 1 for rolling 2 dice together. Oh, shoot. We are late, huh? Okay. Is it almost over? Yeah, 2 minutes, right? All right, let's stop right there.